Hello guys, today we are going to discuss about this problem, number of islands. This is the problem number 200 on LeetCode. So here, as you can see, the problem is something like this, that a island is given, a grid is given, something as input is here, and we have to find number of distinct islands. So the question is given on 2D grid, ones are land and zeros is water. Count the number of islands. An island is surrounded with water is formed by connecting adjacent land horizontally or vertically. You may assume all four edges of grid are all surrounded by water. So here I'll just show you the actual code which I have written. I'll just post it on the LeetCode soon. So the logic here is that if we consider this example, so here if we see these four ones, then these two ones and these two ones, this all form one island. And again, since this one is also connected to this one, this form the same island. So from a position, if you can traverse below, right, left or top, for example here, if you from here you can travel right, left, top and below, and if you find it one, so it will be considered as part of that island only. But if you are not able to find any on these positions, right, left, below and top, then that is not part of that island. Again, let us understand with one more example. So this is an example here. The answer should be 5, because we have the diagonal entries are not allowed, diagonal islands are not allowed. So when we are at 1 position 0 0, we will not find any island connected. This is 0 then and this is also 0, diagonals are not allowed. When we are at 0, since it is water, we will not count. So when we are at 1, we do not have any connected land on left, right is nothing, below is 0 again and top is nothing. For this middle element, if we see all the entries on right, left, below and top are 0, so this is considered as a discrete island. So answer should be 5 here. So how we'll start is we are given a two-dimensional matrix of grid of we are given a two-dimensional matrix grid. So if we see dot size will give us number of rows, and the size of first row will give number of columns in a two-dimensional matrix. Then we have to take a visited array. I have taken it a visited a vector of fixed size, rows and columns, and I have initialized it to 0. Then what the logic is that you have to traverse each and every element on the grid, and if the element if the grid entry is 0 and grid is 1, then we have to count the connected nodes or connected islands to it. So the logic is here, we are just passing grid, we are just passing visited, then we are passing that particular entry, that is if we are starting at 0 0, this is 0 0, then number of rows and number of columns. So this is just a simple calculation that if above present element is 1, that is it's not visited. If it is false, it's not visited, and if it is 1, then what we have to do, we have to just recursively call that element and mark it as visited. So some people might be thinking that we can go with depth first search or breadth first search. So in depth first search we usually use stacks, and in breadth first search we usually use queues. So that is not required here, because pushing into queues and stacks and then popping out will be a costly operation. But what's the logic here is simply, I'll just show you. So when we start at element 1 after that all the elements which are ones and connected to it, we will mark them as visited in the visited array. So we have taken a equal size visited array, so we will mark all these entries as ones here, all these entries as ones, and we are not doing nothing else apart from it. In the function mark connected visited, we are just marking the entries as ones in visited array. Then we return, and so initially it was at 0 0. Then we again start in this outer for loop. At 0 1 we find that this is already visited because we have already made it 1, so we'll not go inside. Then we'll go to at 0 2 0 3, it's not going to come inside. Then it all goes like this. So let's see this example. So we start at 0 0, we mark it as visited, 0 1 is visited, these all entries are gone. So now the loop comes here, and this is 2 second row and second column 2 2, so it comes here. So here 2 2 is 0 in visited array, but grid is 1, so it satisfies this condition, and we count this as a separate island using count plus 1. Then again we go to mark connected visited. So from this node it will check recursively that whether this any of them is unvisited and 1. So if we check the logic here, it should be unvisited and the grid should be 1. So if we found any element, we make it as visited and we go ahead with that. So this is a very simple logic. So I have checked the 3 conditions or somewhere, and it's working fine. So I thought to make the video, and let's not use again one thing left is about the time and the space complexity. The time complexity for this algorithm will be on square. Why? On square plus om, because let's suppose in this case here, if we mark this node as 1, so if we want to reduce the time complexity of this algorithm, so we have to traverse each and every element, right? Because this island is visited, that is fine, but we do not know that the last element here is 0, is 1. That means we have to check each and every element in the array, the distinct element in the array, which can be 1, which can be island. That's why it will be on square all the time. But let's suppose these are 4 entries here marked as island, so these will be traversed twice. So in this recursive function, since we know that in recursion stack frames are allocated contiguously, or maybe we can think of in array format. So whenever we are traversing to a new stack frame, to a new function inside the recursion, it's always linear. So that's why if m number of directly connected ones are there in the island, so its complexity will be om. And why it's added? Because it will not be multiplied, because it will be on square, and then we will traverse m islands, so it will be on square plus om. Space complexity is number of rows multiplied by number of columns which of the original array. So this is a solution, and if you like the video, please do hit the like button. If you have questions, please post in the comment section. Thank you. Have a good day.